Hello geometry students, here's your video for section 1-6, midpoint and distance formula in the coordinate plane. My name is Missy McCarthy and I'm a math teacher at Okemos High School. Your I can statements for this section are being able to recite the midpoint and distance formula. Recite also means memorize. You got to know what those are. Being able to use the midpoint formula to find the midpoint given 2 points, use the distance formula to find the distance between 2 points, and find the missing endpoint when given the midpoint and one other endpoint. So the very first one we're going to take a look at is the midpoint formula. The idea is that you have one endpoint of a line segment, another endpoint of a line segment, and we want to find the point that's in the middle, the midpoint, okay? But instead of just, measuring, we want to find out what the coordinates of that point are if they are in the XY coordinate plane. So let's just put some fictitious points in the XY coordinate plane. I know that these have actual coordinates, but we are just going to do it as if they are arbitrary. So x1, comma y1, and x2, comma y2. So these are two arbitrary points. They're the endpoints to our line segment. And we want to find where the point is that is directly in the middle. So I'm going to call that point M. I'm going to call this point A. I'm going to call this point B. So we're trying to find the midpoint of segment AB. Well, if you want to find directly in the middle between these two x's, essentially what we're doing is finding the average of the two x's. And whatever the average is, that'll be right in the middle. So my x coordinate of my midpoint will end up being the average of the two x's. To find an average, you add them together and you divide by 2. And then your y coordinate of your midpoint will actually end up being the average of the two y values. Add the y values together and divide by 2. So this is what we call the midpoint formula. So if we were going to use that midpoint formula to find the coordinates of the midpoint, given my segment TU, so I'm just going to draw it, again, very arbitrary. We got segment T, or point T, we got point U, okay? We want to find the point right here in the middle. I'm going to call that M for midpoint, so that that's congruent to that, okay? So I'm going to use the midpoint formula now to find M. Sometimes you can write M, or you could write M. Sometimes I just write midpoint. And to find the midpoint, again, the midpoint formula is the average of the x's over 2, and then the average of the y's over 2. So if I plug in what they give me for the x's, I've got 5 and 1. 5 plus 1 divided by 2. And then for the y's, I got -1 and -5. -1 plus -5 divided by 2. So we get for a midpoint, 6 over 2 is 3, and -6 over 2 is -3. So that would be the coordinates of my midpoint. Now we could plot that on the XY coordinate plane, and you would see that that point is in the middle of T and U on that line segment. It's the midpoint of the line segment. Okay, so now we're going to change things up just a little bit because they tell us that y is the midpoint of xz. So we have our segment xz and y is the midpoint. Then they tell you the coordinates of x are 2, 4. So I am going to go ahead and plot the coordinates of x. There's point x, it's 2, 4. And they tell us the coordinates of y, which is -1, 1. That's the coordinate of y. But y is the midpoint, so where is somewhere down here we have to have our z. And the goal is to find the other endpoint, not to just find the midpoint of these two. Find the other midpoint that's somewhere down here. Okay? So this one's a little bit different. What I've had students do in the past is do this graphically. They would say, okay, to get from here to my midpoint, I go down 1, 2, 3, and over 1, 2, 3. That gets me there. So if I want to find the other endpoint, I go down 1, 2, 3, and over 1, 2, 3. And they say, all right, the coordinates of z have to be right there. and then y is directly in the middle. So the coordinates of z, my other endpoint, end up being at -4, -2. So some students like to do it graphically. I tend to do it using algebra and the midpoint formula. I say, all right, I need to find my midpoint. So I know if I take 2 and add it to some other number and divide it by 2, because I got my x coordinate, I add it to the other x coordinate and divide by 2, I have to get -1. And then for the y, I know if I take my y coordinate, which is 4, add it to the other y coordinate, and divide by 2, I have to get the y coordinate of my midpoint, which is +1. So then I multiply both sides by 2, and I get 2 plus x2 equals -2. And then I subtract 2 on both sides, and I get x2 equals -4. For this one, multiply both sides by 2, and I get 4 plus y2 equals 2. Subtract 4 on both sides, and I get y2 equals -2. So you can see that I found the coordinates of my midpoint, but I found it algebraically. So that's, or not midpoint, I'm sorry, that's the end point. So the coordinates of z, again, are -4, -2. So there's 2 ways to do those kinds of problems. All right, now let's move on to the distance formula, which is based on Pythagorean theorem in right triangles. So again, we have our 2 points. We've got our point here. I'm going to call this point A. We've got our point here. I'm going to call this point B. And this is our segment right here. This is our line segment AB. We want to find the length or the distance between those 2 points, or the length of line segment AB. And so we're going to do that using the Pythagorean theorem, because if we were to draw this little segment in here and this little segment in here, we actually form a right triangle where this is our one leg A, this is our other leg B, and then C is the distance, which is what we're really going after. That's what we're actually trying to find, the distance between the 2 points, or the length of this line segment. So I'm coloring that in purple because that's what we're trying to find. So if we use the Pythagorean theorem, which purple is not going to write really well on that. So we've got a squared plus b squared equals c squared. And we know that our distance A is actually just the difference between the 2 x's. If we have an x1 here and x2 here, so this is the x2 distance, all the way over here would be x2, and we subtract them, we get the distance between x1 and x2. So this is just x1 minus x2 quantity squared, or you can do x2 minus x1 quantity squared. It really doesn't matter. Plus the difference between the y values. So y2 minus y1 quantity squared, that gets you the length, equals c squared, or the distance, which is what we're looking for, d squared. Okay, so if we write that with the d squared on this side, d squared is equal to x2 minus x1 quantity squared plus y2 minus y1 quantity squared. And we want to just find the distance, or the c value. We could take the square roots of both sides, and we get the distance formula. D equals the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So this is our distance formula. It's how you find the length of a segment in the coordinate plane, or the distance between 2 points. So they're giving us 2 points here, and it says use the distance formula to find the distance between the 2 points, or the length of the segment. So I'm going to recite the distance formula. Distance equals the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So the distance is equal to the square root of x2, it's -7, minus x1, which is -2, quantity squared, plus y2, which is -4, minus y1, which is 0, quantity squared. That's equal to the square root of, that's going to give me -7 plus 2 squared, and this is going to give me -4 squared. That's the square root of -5 squared plus -4 squared. which is the square root of 25 plus 16, which ends up being the square root of 25, 35, 41. And I don't know what that is as a decimal, but you can find the decimal approximation as well. So that would be the length of segment KL. So you might also see it as written as KL is equal to the square root of 41. The length of KL is the square root of 41. Now for our last example, we have a triangle ABC in the coordinate plane, and it looks like we're being asked to find the lengths of all three segments. So first I'm going to write the coordinates of each of these. It looks like the coordinates of A is 1, 2, 3, 4. So it's 3, 4. The coordinates of B is 1, 2, 3, negative 1. And actually, A is 1, 2, 4. My bad. And then C is negative 2, 0. Okay. So essentially, we have to do the distance formula 3 times. So the first one I'm going to find is AB. And that's going to be equal to the square root. I need the difference of the x's of A and B. So 2 minus 3. I made that too big. 2 minus 3 quantity squared plus the difference of the y's, 4 minus a negative 1 quantity squared. So I'm going to try to simplify this. That's going to give me negative 1 squared, which is 1. So the square root of 1 plus this is going to give me 5 squared, which is 25. So this turns out to be the square root of 26. Now I'm going to find BC. So I have to make sure I'm looking at the right points when I do my differences. So BC would be 3 minus a negative 2 quantity squared, and negative 1 minus 0 quantity squared. That's going to give me the square root of, that's going to give me 5 squared, which is 25, and this is going to give me 1. So that's also the square root of 26. And then the last one, AC, square root, squared, and make sure I'm looking at A and C. 2 minus negative 2 squared, 4 minus 0 squared. We get the square root of, that's 4 squared, which is 16. This is 4 squared, which is 16. And that is the square root of 32. So I've got all three of those distances. So AB is the square root of 26. BC is the square root of 26. And CA or AC is the square root of 32. And then it asks which two pairs of segments are congruent, and we see that segment AB is congruent to segment BC. All right, so there was a lot of computation there, but by the end of this video, you should be able to recite both of those formulas, to use the formulas to find midpoints and distances, and to find the missing endpoint when you're given the midpoint and another endpoint. See you in class.